In this video, we're going to do some practice with conic sections in polar coordinates. So let's start off with r is equal to 12 over 4 minus 2 cosine of theta. So we're going to rewrite this into proper form. So what you can do is factor out a 2 from the denominator, and that's going to be 2 times 2 minus cosine of theta is equal to r, and r is equal to 6 over 2 1 minus 1/2 cosine of theta. So r is equal to 3 over 1 minus 1/2 cosine of theta if you simplify. Now, after this, you have to identify the parameters. So we're going to compare this with an equivalent form that just has the general variables and not actual values plugged in, so we can clearly see what the things are. So r is equal to EP over 1 minus e cosine of theta. So that means we can clearly say that e is equal to 1/2 and EP is equal to 3. So if we solve for p is equal to 3 over 1/2, and that's equal to 6. Now, if p is equal to 6 and our e is equal to 1/2, we can see that e is less than 1, so that means that you have an ellipse. Now, how can we figure out our directrix? Well, if we have the form where we have 1 minus e cosine theta, that means that we have a directrix that is to the left of the pole. Directrix is left of the pole. So the distance from the pole to the directrix is going to be x is equal to -6. Now, how do we find our polar axis ints? So that's going to be by setting theta equal to 0. You're going to have r is equal to 3 over 1 minus 1/2, and that's going to equal to 6. So you're going to be at the point 6, 0. After that, you're going to have theta is equal to pi. So that's going to be when you have r is equal to 3 over 1 plus 1/2, and that's equal to 2. So that's going to be at 2 pi. Now, how would you graph this? Well, you would graph this by setting your directrix equal to x is equal to -6. So this is your directrix. And you would draw your focus at the pole, and you would plot your intercepts here. And you would draw your horizontal ellipse. So this would be a horizontal ellipse because of the fact you have cosine theta. And it's going to be symmetric about the polar axis. Now, moving on to our next example, we are going to have for r is equal to 9 over 3 plus 3 cosine theta, we're going to put this into proper form. So we can factor out that 3. So that's going to be 9 over 3, 1 plus cosine theta. Now, you can actually divide that out, and you can get rid of that 3. And that's going to be equal to r is equal to 3 over 1 plus cosine of theta. Now, after this, we can see that this is reflective of r is equal to EP. Not a reflection, it just means, when I say that, I mean it's similar to e cosine of theta. So here you can see that e is equal to 1, EP is equal to 3, and p is equal to 3. So now we can see that if e is equal to 1, that means that you have a parabola. And because we see we have 1 plus e cosine of theta, that means that the directrix is going to be right of the pole. And because it's right of the pole, we know that the pole is at 0, 0. So that means that if we were to graph where the directrix is, it would be at x is equal to 3. It would be that vertical line there. Now, after this, we need to find our polar axis intercepts, our polar axis ints. So at theta is equal to 0, you would have r is equal to 3 over 2, and that would be the point 3 over 2, 0. Now, if you have theta is equal to 0, or theta is equal to pi, you would have r is equal to 3 over 1 minus 1. Now, you would get 3 over 0, and that would give you something that's undefined in your asymptote direction. Now, if you were to graph this, you would first start off with plotting the focus at the pole. Then you would draw your directrix at x is equal to 3. You would plot the intercept 3 over 2, 0, and then your parabola, it would open left. And that's because your directrix is on the right of the pole, and your pole is the location where your conic section is. So that means that your parabola has to be opening to the left. because the directrix is on the right. Now, for our next example, we are going to do r is equal to 20 over 5 minus 4 sine of theta. Now, first we're going to rewrite this equation. So we're going to factor out the denominator. You're going to have 20 over 5, 1 minus 4 over 5 sine of theta. And this is going to cancel. You can cancel that 20 over 5. So that 20 divided by 5, that would just be equal to 4. And you would have r is equal to 4 over 1 minus 4 over 5 sine of theta. Now, here you can clearly see that e is equal to 4 over 5, and that EP is equal to 4, and p is equal to 5. So, because you can see that e is less than 1, you can see that it's an ellipse. And in order to find the directrix, we again look at our relationship with this minus here. And because we see we have sine theta, that means that your directrix is going to be horizontal. It's going to be a horizontal directrix. And because it's minus, that means it's going to be below the pole. So essentially your directrix is going to tell you the location, or the location of your conic, aka it's essentially going to guide it. It's kind of like an asymptote, and where it can be and where it cannot be. So it's going to be below the pole. So we can see that p is equal to 5, and we know that our directrix has to be 5 away from the pole. So our directrix is going to be y is equal to -5. So that's going to be that horizontal line at -5. Now we have to find our polar axis intercepts, our polar axis ints. And we do this with theta is equal to pi over 2. So r is going to equal to 4 over 1 minus 4 over 5. And we know that 4 is equal to 4. So 1 can be written as 5 over 5. So you get a common denominator, minus 4 over 5. And that's going to be equal to 4 over 1 over 5. And you would just flip the fraction here. So that would be 4 over 5 over 1. So that would be equal to 20. And that point would be 20 pi over 2. Now, what about theta is equal to 3 pi over 2? That would be when you have r is equal to 4 over 1 plus 4 over 5. And this would be when you have rewritten like this. You could have 4 over 5 over 5 plus 4 over 5 is 9 over 5. And that would be 5 over 9, and that would be 20 over 9. So then you would have the point of 20 over 9, 3 pi over 2. Now, how would you graph this? You would graph with your plotted point of focus at the origin. Then you would draw your directrix at y is equal to -5. Then you would plot the intercepts, and then you would sketch that vertical ellipse. It would be a vertical ellipse because of the fact that you have a sine theta, not a cosine theta. Now, for our final question, we are going to have r is equal to 15, 5 minus 3 cosine of theta. So you would rewrite this, and you would have r is equal to 15 over 5, 1 minus 3 over 5 cosine of theta. And this would be equal to, if you divide 15 by 5, you would get 3. So you would have r is equal to 3 over 1 minus 3 over 5 cosine of theta. And here you can easily see that e is equal to 3 over 5, and ep is equal to 3. And from that, if we know that e is equal to 3 over 5 and ep is equal to 3, that means that p must equal to 5. And we can see that e is less than 1, so you're going to have an ellipse, and it's going to be a horizontal ellipse because you have cosine of theta in this problem. Now, how do we find our directrix? Well, our directrix, we can see we have a minus sign, so that means your directrix is going to be left of the pole. And using the fact that p is equal to 5, that means we know that x is equal to -5 because p is equal to 5. Now, after this, we need to find our polar axis intercepts as we have done for each of our previous problems. So you're going to have theta is equal to 0 and r is equal to 3 over 1 minus 3 over 5. Now, that's going to be equal to 3 over 5 over 5 minus 3 over 5. And that's going to be 3 over 2 over 5. And that's going to be 3 times 5 over 2, which is 15 over 2. So that's going to be 0.15, 15 over 2, 0. Now, what about when you have theta is equal to pi? Well, this is going to be r is equal to 3, 1 plus 3 over 5. And you're going to have 15 over 8. That's going to be 15 over 8 pi. Now, how would we graph this? You would first start off with plotting your focus at the pole, then you would draw your directrix at x is equal to -5, then you would plot your intercepts, and then you would sketch that ellipse, and it's going to be symmetric across your polar axis. So in general, what you have to do with these types of problems is you always want to get your proper form. And by proper form, we mean that a form where it's easily visible what r is equal to EP over 1 plus or minus e cosine of theta, or you want it to be in the form as r is equal to EP divided by 1 plus or minus sine of theta. Then that's gonna be your first step. Your second step is you're gonna find what EP and EP are. And then after that, you identify your conic type by e is less than 1, that's your ellipse. E is equal to 1, that is your parabola. And e is greater than 1, that is your hyperbola. Now, after that, your fourth step is going to be finding the directrix. You find your directrix. So if you have 1 minus e cosine of theta, that is going to be your pole, right? So this is going to be your pole, and it's going to be to the left of the pole. Now, if you have 1 plus e cosine of theta, that's going to be here. You're going to have it to the right. Now, 1 minus e sine of theta, that is going to be like this, and you're going to have it below. And finally, 1 plus e sine of theta, you're going to have your graph here, and then you're going to have it above. So, and then for your final step, for step 5, you're going to plug in the easy values of theta is equal to 0, pi, pi over 2, 3 pi over 2, you choose, to get your polar, or it could be either axis, but it's to get your intercepts. Now, after this, let's do some more practice problems. So, let's say we want to tackle with forms where we have to convert a polar conic into a rectangular equation. So we're going to go from polar conic to rectangular equation. And we're going to use x is equal to r cosine of theta, y is equal to r sine of theta, and also r squared is equal to x squared plus y squared. Now, we can start off with our first question where we have r is equal to 2 over 4 minus 2 cosine of theta. We can clear the denominator by having r is equal to 4 minus 2 cosine of theta is equal to 2. And what we did was we basically just multiplied 4 minus 2 cosine of theta to each side. And that is what your result is going to look like. After this, you can just distribute, and you're going to get 4r minus 2r cosine of theta is equal to 2. Now, you're going to replace, let's take this here. So we have a copy here away from our master chart. So we can see that r cosine of theta is going to be equal to x, right? So we can replace that here, and you're going to rewrite this as 4r is equal 4r minus 2x is equal to 2. After this, we just solve for r. And after this, you're just going to divide by 4. So r is equal to 2x plus 2 over 4. But we can simplify this. R is equal to 1 plus x over 2. Now, after this, what we want to do is we're going to square both sides. And you're going to get r squared is equal to 1 plus x over 2 squared. We're just going to leave it like that. And actually, let's just 1 plus x squared over 4. Now, we know that r squared is going to be equal to this relationship here, so we can substitute that in, actually. And you're going to have x squared plus y squared is equal to 1 plus x squared over 4. Now, what you want to do next is you want to multiply through by 4. So we're just going to multiply both sides by 4. And this is going to give us 4x squared plus 4y squared is equal to 1 plus x squared because of the fact that this cancels out. And you can expand your right side, so that's going to be 1 plus x, 1 plus x, 1 plus x plus x plus x squared, and you have 1 plus 2x plus x squared is equal to 4x squared plus 4y squared. And now you have to move everything to one side. So what we would do is just make everything equal to 0 on this one side. So minus 1 minus 2x minus x squared. Over here, let's do the same thing. And what we're going to end up here is we're going to have 3x squared plus 4y squared minus 2x minus 1 is equal to 0. Now you want to take this and you want to go into your standard form. So what this means is you're going to have 3x squared minus 2x plus 4y squared is equal to 1 by grouping the x terms. So what you're going to do is you're going to factor that 3 out here. So we would just do that from here. So what I want you to do here is just like ignore that y squared. So you're just going to take that 3 out from here. And you can do this rule where you just divide it, right? So you're just going to write this like this. You're going to have 3x squared. Actually, don't do this. This is really weird and you don't want to do something weird like this in math. So we're just focusing on this part here with the x's. X squared minus 2 over 3x plus 4y squared is equal to 1. Now, what you're going to do here is you're going to complete the square inside. So we're going to do x minus 1 over 3 squared 1 minus 1 over 9. So that's going to be what's inside of there. Plus 4y squared is equal to 1, 3. Now you're going to distribute that 3 actually. And you're going to multiply through. Or no, it's just in here actually. So you're going to end up with 3x minus 1 over 3 squared minus 1 over 3 plus 4y squared is equal to 1. And now you're going to add 1 over 3 to both sides. And after this, you have 3x minus 1 over 3 squared plus 4y squared is equal to 4 over 3 because 1 over 1, or 1 is equal to 3 over 3. 3 over 3 plus 1 over 3 is 4 over 3. And you have 9. Because what you can do here is you can multiply both sides by 3. Again. So that would multiply, and you would have 9x minus 1 over 3. Let's do this in a different color. 9x minus 1 over 3 squared plus 12x. 12y squared is equal to 4. Now, after this, you would divide by 4 because we want to get it to be just 1, right? So we can just divide both sides by 4 here, and that would be 1. So you would have x minus 1 over 3 squared over 4 over 9 plus y squared over 1 over 3. And yay, now we don't have anything in front of here, so that's good. That's equal to 1. So now this rectangular equation, So this is now a rectangular equation. And we can see that both of these terms, they're going to be positive. So we have an ellipse, and now this is complete. Now let's do another example. Let's say we have a problem r is equal to 6 over 2 plus 3 sine of theta. So what we're going to start out by doing is we're going to clear the denominator. So we have r is equal to 2 plus 3 sine theta is equal to 6. And this is going to be 2r plus 3r sine of theta is equal to 6. And again, we have our relationships here, which I'm going to bring over. And let's make sine of theta. Let's make sine of theta green. So sine of theta, we're going to replace that with y. We're going to have 2r plus 3y is equal to 6. We want to solve for r. So we have 2r. Let's just subtract 3y here visually. And we have 2r is equal to 6 minus 3y. And you can divide both sides by 2. So r is equal to 6 minus 3y over 2. After this, you're just going to square both sides. And you're going to have r squared is equal to 6 minus 3y squared over 4. Now, using r squared, we know that r squared is equal to x squared plus y squared. On the other side, you're going to have 6 minus 3y squared over 4. Now, we're going to expand both sides after we multiply 3 by 4, because we want to get rid of that 4. And this is going to be 4, so we can multiply those. This is going to cancel, and you're going to have 4x squared plus 4y squared is equal to 6 minus 3y squared. So this is going to be 6 minus 3y, 6 minus 3y, and that's going to be equal to 36, negative 18y, and negative 18y. And this is going to be positive 9y squared, and that's going to equal to 4x squared plus 4y squared. After this, you want to move everything to one side. What you'll be left with is 0 here. So this is going to be 4x squared plus 4y squared minus 36 plus 36 plus 36y minus 9y squared is equal to 0. And here what we can do is we can simplify this again. We're going to have 4x squared minus 5y plus 36y minus 36. Because what we can do is just combine that here, and you're just going to have that is equal to 0. So let's put this into standard form now. So here our goal is to get this into standard form. So you're going to have to group the y terms. So we have x here, and we have y terms here, minus 5y squared. So you're going to have your 4x squared minus 5y squared minus 36 over 5y minus 36 is equal to 0. So you're going to complete the square in here. You're going to have y squared minus 36 over 5 is equal to y minus 18 over 5 squared minus 324 over 25. So put this in parentheses, and this is going to be minus 36 is equal to 0. So this is going to be 4x squared minus 5. And after this, you're just going to distribute that 5. And you're going to have 4x squared minus 5y minus 18 over 5 squared plus 324 over 5 minus 36 is equal to 0. And we know that 36, if we convert this into fifths, this would also be something with a common denominator of 5. So 180 over 5. So that would be 180 over 5 plus 324 over 5 minus that. So this would be equal to 144 over 5. So we can add that back to our equation and add everything back. So that would be 4x squared minus 5y minus 18 over 5 squared plus that. And you would have, if you move your terms, you would have 5y minus 18 over 5 squared minus 4x squared is equal to 144 over 5. After this, you're going to divide both sides by this 144 over 5. 144 over 5, because you just want to get this side equal to literally 1. And this is going to be y. So we see we have this 5 here. We have y. Actually, that 5 doesn't cancel, but we would have this. Minus 18 over 5 squared minus x squared over 36 over 5 is equal to 1. That'd be 144 over 25. And this is going to be your solution. Even though it's messy, this is going to be your hyperbola because you have one term that is positive and one is negative. So now moving on to our third question. For our third question, we are going to have our 1 minus sine theta is equal to 3. So we get this. This is going to be from r is equal to 3, 1 minus sine of theta. So now what you're going to do is, you see sine of theta, take these same things here. You're going to replace r sine of theta with your y. So this is going to be r minus r sine of theta is equal to 3. So before this, we have r minus y is equal to 3. This was r minus r sine of theta is equal to 3. So this would have been here. You had sine theta and you replace that with y. Let's actually move this here because it's not the step where we did it. And after this, you're going to square both sides. So let's make a little room for this. We're going to square this side and we're going to square this side. So you are going to have your this, but before this, we can solve for, before we do this, let's actually solve for r. So this was what we got. So we're going to add y, and r is equal to 3 plus y. 3 plus y. So now we can just square both sides. So that's going to be r squared is equal to 9 plus y squared. And what we can do before we do that, we can just leave it as y plus 3 squared for now. So we can replace r squared with x squared plus y squared, and that's going to be x squared plus y squared is equal to y plus 3 squared. Now, if you expand this, this is going to be equal to y squared plus 6y plus 9 on this side, because y plus 3, this helps you, y squared plus 3y plus 9. And you have your x squared plus y squared. That's on both sides, so that can cancel out. So you're left with x squared 6y plus 9. So you can factor out that 6. So you could write either of these as your equivalent final form. And this is going to be a parabola. Reason being, you have only one squared term, aka variable, because you only have one squared term, because if it was different terms, you could have just like added them because it would have been of the same power. But here we only have one variable. We have like terms. All those like terms, they would have just simplified to x squared. So in general, the pattern that we've been seeing so far is that what you want to do first is you want to multiply both sides by your denominator. for example, you have r is equal to something, something plus something, cosine of theta. This would become r b plus c cosine of theta is equal to a. Then you would replace, and this would be r is equal to cosine theta is equal to x, r is equal to sine theta, which is equal to y. And after this, you would solve for r. You would square both sides, and then you would replace. R squared is equal to x squared plus y squared, and then you would simplify and complete square if needed.